Hello students, a very good morning. So welcome in lecture number 3, chapter solution. So till now what we studied in this chapter, we discussed about the solution and the type of the solution as homo and heterogeneous, and then further the component of the solution as solute and solvent, and then the division of solution as on the basis of the mass and the volume. Then we discussed a few terms with respect to the weight by weight percent, weight by volume, volume by volume, right? And today what we are going to discuss, we are going to discuss the ppm, molarity. So we discuss this concept and the questions which are based on it. Okay. So now here ppm. What is ppm? ppm is your parts per million. That means 10 to the power 6. If I will say that sugar 2 ppm in solution, it means what? It means 2 gram sugar is present in 10 to the power 6 gram of solution, right? So if you write the formula as we did in case of your weight by weight percent, weight by volume percent, how we will write it? We will write it as number of ppm is equal to the mass of solute is divided by the mass of the solution multiplied by 10 to the power 6. Okay. So in very few cases you will get the questions which are based on this concept. So in this case you must know that which formula you will use and how you will calculate the values when they are going to ask you in ppm, right? Now the next term is your molarity. So all of you will be very much familiar of this term molarity. So what is molarity? Molarity is number of moles of solute which are present in 1 liter of solution, right? So if I write the 2 molar, then you will say that the 2 moles of sugar is present in 1 liter of solution. That's it, right? If I write the 3 molar, that means 3 moles of sugar is present in the 1 liter of solution. In the same way, if I will write that the molarity of H plus ion is 3 molar, it means what? Molarity of H plus ion is 3 molar. That means 3 moles of H plus ions are present in 1 liter of solution. So in the same way you can do the problems which are based on your concept, based on the concept of your molarity. So what is molarity? Molarity is the number of moles of the solute which are present in the 1 liter of solution. Okay. Now here I have given you the one question based on the concept of your molarity. It is find the molarity of 40 gram NaOH dissolved in 500 ml solution. So what you have to calculate? Molarity, right? So molarity is what? Number of moles of solute is divided by the volume of solution in liter. Okay? So N is representing the number of moles of solute. So what is solute here? This is NaOH, right? So you have to calculate the moles. So what is moles? Moles is weight upon molecular weight, right? So in case of NaOH, you will calculate the molecular weight of NaOH, we will get as 40. How and why? See, so in case of sodium, the atomic mass is 23, for oxygen it is 16, for hydrogen it is 1. When we will add together, we will get the 14, right? So the N is equal to what? The weight of NaOH divided by the molecular weight of your NaOH. So that means if we put the values in place of N, we will get 40 upon 40 is divided by now. See the volume of solution in liter. Okay. So here what they have given in 500 ml. 500 ml means what? You need to divide it by the 1000 to convert it into the liters. Okay. Right. So here what you will write, 40 upon 40 is divided by 500 upon 1000 is equal to the 2 molar. So the molarity of 40 gram NaOH which is dissolved in 500 ml solution is 2 molar. Okay. Now see the question number 2. Now this question you try to do on your own. Okay. See, 4.9 gram H2SO4 is present in 500 centimeter cube of solution. What you have to do, you have to calculate the molarity. Okay. So just for your information, I have given you the final answer and that is your 0.2 molar. Just go through the procedure and tell me whether you are able to find out the answer in a correct way or not. And what is your answer? Okay. The second question is written for you. Find the mass of Na2CO3 present in 100 ml 3 molar solution. See, in this question they have given it in another way. How? They have given the molarity. And what? They have given the volume in ml. You have to calculate the mass. Right? So from the formula of the molarity, as we know, that the molarity is what? Number of moles of solute is divided by the volume of solution in liter. And what is the number of moles of solute? It is the weight upon molecular weight, right? So we have to calculate this weight because we have to calculate the mass of Na2CO3, right? So what we will write? We will write 3 molar is equal to weight upon molecular weight of Na2CO3 is divided by the volume in liter. So in that case, you need to change this ml into the liter. Then you will get a final answer, and here I have written again the final answer of this question, which is 31.8 grams. Now here I have written the few terms that you need to keep it in your mind for your board as well as competitive exams point of view is very important. See, for if they have given the molar, that means the one you need to write, right? You will think that it is a 1 molar solution. If they will give you the bimolar, it is understood that it is 2m. That means 2 molar. If they will write the semi-molar, don't get panic because semi-molar is nothing but your m by 2. That means m by 2 is representing the semi-molar. And for the decimolar, what we are using? We are using m by 10. In case of your centimolar, they are using m by 100. Okay? So in this way, if they will not give you the molarity clearly and they will give you in a twisted way, something like decimolar, semimolar, that time you need to understand that they are talking about which type of the molarity. Okay, I hope it is clear. Now go to the next question. The question, if 53 gram of Na2CO3 is dissolved in 500 ml solution, then find out the molarity of this. Okay. Number 1, Na2CO3, Na plus ion and carbonate ions. What you have to calculate? You have to calculate the molarity of sodium carbonate, sodium ion and the carbonate ions. So now see, as we know this much gram of Na2CO3 is dissolved. So this one is your solute and this is the weight. When we divide with the molecule, divide it with the molecular weight of Na2CO3, you will get the number of moles of Na2CO3, right? But they are dissolved 500 ml, so we can change it into the liters to calculate the molarity, right? So for the Na2CO3, 53 is divided by 106. What is 106? 106 is the molecular weight of your Na2CO3. Is divided by 500 again, divided by 1000, then you will get the 1 molar. Okay? So if you will write the complete dissociation of your sodium carbonate, you have calculated the molarity of this one. What you have to find out now, you have to check the sodium ions molarity and the carbonate ions molarity. Okay, so how you will do it? You need to check the complete dissociation of your Na2CO3. Suppose if this is happening, then how you will get and what you will get after the dissociation? You will get the 2 moles of sodium ions and the 1 mole of your carbonate ion, right? So see, here 1 mole of sodium carbonate is dissociating into the 2 moles of your sodium ions and the 1 mole of your carbonate ions. And suppose this one is present in 1 liter, this one is present in 1 liter, this one is again in 1 liter. So here we can check that the molarity for the Na2CO3 as is calculated, we calculated it as 1 molar. That means for the 1 mole we are getting the 2 moles of sodium ions. That means if we are having the 1 molarity of this one, because the liters are same, we will say directly that we will get the 2 molar of your sodium ions. In the same way for the carbonate, what we will write, because from the 1 mole of sodium carbonate, how much carbonate we are getting, how much moles of the carbonate we are getting? 1 mole. So that means for the 1 mole of your 1 molarity of this one is, if we are calculating that, it will come same as for your carbonate ions, right? So here for the carbonate ion molarity is 1, for the sodium ions it is 2, for the sodium carbonate it is 1 molar. I hope everything will be very much clear to you now. So keep study, stay safe at home. Thank you.